Another situation which relates to exponential decay is called Newton's law of cooling. The rate at which an object cools is proportional to the temperature difference between the object and its surroundings, provided that the temperature difference is not too large. We end up with this formula. As an example, let's suppose there's a cup of coffee that has an initial temperature of 200 degrees and is placed in a room that has a temperature of 70 degrees. After t minutes, we know the temperature drops to 150 degrees. So the first two bits of information are enough to get us started. So the initial temperature and the temperature of the environment are two things I need. So T sub S is 70, and the difference is going to be 200 minus 70. We get the temperature at time T is going to be 70 plus 130 e to the negative kt. And now, after 10 minutes, in other words, at time t equals 10, we know that the temperature is 150 degrees. So we can use this information to find K. And I encourage you to try to do that on your own before watching the explanation in the video. So the equation that we can use to solve for K is 150 equals 70 plus 130 e to the negative k times 10. If I subtract 70, I get 80, and if I divide by 130, I get 80 over 130 equals e to the negative 10k. And then, of course, we can apply natural log to both sides, and we end up with k equals the natural log of 80 over 130 divided by negative 10. And we can use this to find a value for K of about 0.0486. And then putting this together gives us our model. So the temperature at time T in general is going to be given by 70 plus 130 e to the negative 0.0486 T. Now, again, I encourage you to pause the video and try to use that model to solve parts B and C. So part B is pretty straightforward. We just need to find the temperature after 15 minutes, and we can do that by plugging 15 into our formula. And with a calculator, you should see that we end up with something about 132.7 degrees Fahrenheit. A second question, when will the coffee have cooled to 100 degrees Fahrenheit? So in this case, we're looking for an amount of time, and I can take the given value of temperature and set our model equal to that. So 100 equals 70 plus 130 e to the negative 0.0486 t, and solve that for t. Can subtract 70 from both sides and divide by 130 to get 30 over 130 equals e to the negative 0.0486 t. And then applying natural log to both sides is going to give me the natural log of 30 over 130 equals negative 0.0486 t. And so, of course, t equals the natural log of 30 divided by 130 over negative 0.486. Sorry, negative 0.0486. Plugging that expression into a calculator, we see 30.17 meaning it will take about 30 minutes for the temperature to reach 100 degrees.